So far, very little is known about their world below the surface. But scientists have a pretty good understanding of the sea lion's life on land. Sea lions breed on rocky islands, and females give birth to just one pup in the spring. They're born into a rough and rowdy world. This is about as gentle as it gets for a pup. And recently, things have gotten worse. Most of these pups will be dead within a few years. The big question is why?
By looking at these rookeries year after year, scientists can get an accurate count of how many of these youngsters are dying. So I joined an expert who's been studying sea lions for more than 30 years, Ken Pitcher.
We'd like to do no problem.
Okay, sounds great. In Alaska, the decline has occurred from Prince William Sound through the Gulf of Alaska and then out through the Aleutian Islands. Just to get a little idea of the magnitude of the decline, it's really quite striking. This was taken in the 1970s. This is another photo of the same rookery taken during the 1980s and then during the 1990s. And as you can see, the difference is quite striking there.
I was horrified to learn from Ken that sea lions have declined by an amazing 80%, and they're vanishing without a trace. It's so rare to see a dead sea lion that I'm really surprised to find this one, and that's part of the mystery. There's lots of death, but no bodies. If all the dead animals were washed up on the beaches, there would be international outrage. But no bodies means no news, and no news means the world has virtually no idea of the tragedy unfolding here.
But who or what is killing them? Are humpback whales beating sea lions in the race for food? Could killer whales be hunting and eating them? Have we polluted the ocean and broken the food chain? Or are sea lions simply tangled up in our incessant need to take fish? Are fishermen guilty? Or is nature itself somehow responsible? Could natural changes in the ocean be causing the sea lion's decline? It's no surprise that in searching for answers, biologists consider the most likely suspects first, and at the very top of the list is the sea lion's food. It's thought they might be starving to death. Sea lions eat fish, especially herring, salmon, and pollock. And since pollock is such a large part of their diet, people were bound to make connections between the fishery and sea lion declines. Many think it's no coincidence that the pollock industry expanded in the 1970s into the largest fishery in the world. Just as sea lions began to disappear, it looked like fishermen had been caught holding a smoking gun. In July of 2000, the Federal District Court ruled on the issue, and Steller sea lions finally made the news, big time.
The world's largest sea lion at the center of a controversy that could cost the world's largest fishery dearly. In a teleconference today, the National Marine Fisheries Service announced it will close all fishing for pollock, Pacific cod, and Atka mackerel in 2/3 of the sea lion's critical habitat. The environmental group Greenpeace, whose lawsuit triggered the action by the National Marine Fisheries Service, says its intent is not to hurt coastal communities, but to stop the large-scale industrial fishing. A rare show of support among the different, often fiercely competitive sectors of the fishing industry, galvanized today in a plea for help.
There isn't a fishing family today, west of Kodiak, that isn't in fear of their own financial livelihood.
Really, we've been told that this is what's going to happen with little or no public input. on science that is speculative at best and wrong at worst.
I was distressed to see the pain that the sea lion declines were causing. And what's more, the fishermen think they've been framed because pollock are more abundant than ever. They also claim that sea lions are being killed by another suspect, killer whales. Sea lions and killer whales have coexisted for thousands of years. But if killer whales started slaughtering sea lions? I joined pollock fisherman Jay Stinson and asked if anyone had witnessed killer whales attacking sea lions.
Oh, you bet. There's footage of these transient killer whales operating right inside the harbor.
Fishermen have to be good observers to do their job, and their video recordings are proof that killer whales eat sea lions. These seem to be thrashing the sea lion to death with their tails. In another part of Alaska, scientists found a killer whale with the remains of at least 13 sea lions in its stomach.
Scientists aren't sure what role these deaths play in the declines, but they do suspect that killer whales could now be keeping depleted sea lion populations down to low levels.
Guilty or not guilty, killer whales and pollock fishermen are being blamed for sea lion declines. But I had a hunch that the story couldn't be that simple, and there must be other causes for the sea lion's sad demise.
To compound the mystery, there is a part of the Alaskan coast where sea lions are actually increasing. To find out why, Shane must travel 1,000 miles to the east.
Southeast Alaska is just such a beautiful place, with snow-capped mountains and glaciers plunging into deep fjords. I always love watching sea lions, and it's great to see the haulouts crowded with animals over here. They're really amusing. I think if there were only a dozen sea lions left in the world, they'd still be laying in a pile somewhere and complaining that there's not enough room. Sea lions are doing well here, but why? It seemed that to answer this question, I'd have to go back to basics and learn how this ocean system works.
The ocean is in constant motion, especially here in Southeast Alaska, where the mighty Pacific collides with a mountainous landscape. Deep fjords magnify the currents into raging torrents, which makes filming underwater a real challenge. But these currents are the source of Alaska's richness. They drive nutrient-rich water up into the sunlight, creating phenomenal plankton blooms that feed great swarms of krill and copepods.
It's bizarre swimming in this living soup, but these swarms form the first link in the food chain, and these tiny creatures feed one of the largest creatures, humpback whales.
The fact that 30-ton whales can survive on these tiny crustaceans is evidence of their phenomenal abundance. But what do plankton and whales have to do with sea lion decline? Commercial whaling exploded in Alaska in the late 1800s. At least 40,000 whales were killed. The killing only stopped 30 years ago, when 90% of the whales in these waters had been slaughtered. Fortunately, some survived, but scientists calculated that removing such a huge number of krill-crunching whales was likely to have upset nature's balance, leaving large quantities of uneaten plankton for other creatures, like fish. But killing whales didn't benefit all fish equally. Small fish, such as herring, may have lost out to a serious competitor, pollock. The larger, aggressive pollock increased, while the herring declined. You'd think more pollock would be good news for sea lions. But an interesting study at the Marine Science Center at Vancouver Aquarium is revealing an unexpected twist to the sea lion story. The studies have been carried out both in the wild and in captivity, allowing Dr. Andrew Treitz to learn more about the Stellar's diet. His team has trained several sea lions to allow them to measure food intake.
I guess when we first started, there was a lot of controversy about what role did pollock play in the decline of Steller sea lions. Some were saying that Steller sea lions were starving to death because they couldn't get enough pollock to eat. Other people were saying the trouble is they eat too much of it. They're calling pollock the junk food of the sea. And what we've discovered is that Steller sea lions lose out 3 ways when they eat pollock.
Cody is one of 9 Steller sea lions. This teaches a lot about the nutritional value of different types of fish that they're eating in Alaska. We've learned, for example, that pollock costs an animal a lot more to digest. They get fewer calories from it, and the bigger fish, such as pollock, are much harder to digest than the smaller fish, such as herring. So for a Steller sea lion to get by on pollock, you would have to consume about 35 to 80% more pollock than herring, just to acquire the same number of calories.
While the animals were eating herring, they were getting heavier each day. When the animals were switched onto pollock, we saw them losing weight each day until we stopped the experiment and put them back onto herring, and they began to regain that weight. But certainly, if you're going to look at what is the staple food for Steller sea lions, I would say it's herring. That is their bread and butter.
Treitz research proves that sea lions thrive when they eat herring. So herring is a likely key to solving the mystery of their declines. But herring is an important food for many creatures, and the competition for it is enormous. Could whales be part of the problem? With whales eating so much herring, you might think fewer whales would mean there'd be more herring left for sea lions. But it seems to be just the opposite. It's a complex theory, but here's how it works. When most of the whales were killed decades ago, more plankton became available, and pollock flourished. But pollock don't just eat plankton. They also eat herring. And now, the huge numbers of pollock are consuming 10 times more herring than whales ever did. Killing whales has probably turned out to be very bad news for sea lions. But there could be a force even more powerful than humans affecting sea lions: the weather. Decades of fish trawling surveys have revealed dramatic changes in the numbers of many species here in Alaska. These changes have been monitored by a scientist who's been sampling marine life for more than 30 years, Dr. Paul Anderson.
When I started in the early 1970s, our shrimp catches were almost pure shrimp with small amounts of forage fishes like capelin. Starting in 1970 through the 80 period, we saw an influx of some large predator fishes, such as seen here, the Pacific cod, into the nearshore areas. And by the 1980s and through the present time, our catches are now dominated by large numbers of groundfish, and shrimp have declined to only just a token amount. Herring has also shown some rather significant declines. By 1986, we were down to very small token amounts of herring in our survey trawl catches.
The decline in herring looks like a disaster for sea lions. And when Anderson discovered that dramatic changes in fish populations coincided with a 4-degree rise in water temperature, which is huge for the ocean, suddenly it looked like even the weather was partly to blame for sea lion declines.
Diamonds are a miracle of nature. Now, by rights, they shouldn't exist at all. You see, carbon in its natural state occurs as graphite, like found in pencil lead, or as coal. However, every school child knows that when Superman takes a lump of coal and squeezes it with super strength, it turns into the magic of a diamond. How's that possible? In the Earth's crust, if you were to heat up graphite, squeeze it with enormous temperatures, then the bonding angle can change, and all of a sudden you have the fantastic arrangement called diamonds. Diamonds shouldn't exist. They are an accident of nature. The secret of the diamond lies in the carbon bond. Carbon is one of the most plentiful substances known to science. We find carbon in plants, animals, and our bodies, carbon everywhere. And yet diamonds are some of the rarest, most beautiful of all substances. What's the link? The link is the extremely rare environmental conditions that take ordinary carbon coal, for example, and turn it into diamonds. We're talking about deep inside the Earth's crust. We have the pressures, the temperatures, sufficient to distort the bonding angles of the carbon atom. It takes millions of tons of rock. It takes pressure and temperature. In some sense, it takes the entire planet Earth to turn coal into diamonds.
Diamonds are not forged in the Earth's crust, where most other rocks are made. They come from much deeper, from 100 miles within the Earth's interior. And occasionally, in bursts of intense violence, this buried treasure rockets to the surface, carried by special high-speed volcanoes.
Both the microscopes and the observations through them were mostly made in what is now Germany. First came the microscopic discovery in the 1830s and 40s that plants and animals are composed of cells, the basic unit of all living things. It was also noticed that within the cell is a central structure, which was termed the nucleus. Then came the realization that a plant or animal grows through the multiplication of its cells. In the 1850s, this led to the cell theory of life, which the German scientist Rudolf Virchow spelled out in his famous statement, "All cells derive from pre-existing cells."
All living things are composed of tiny cells, so small they can only be seen under a microscope. Every human being is made up of trillions of cells, and each cell contains about 50,000 genes. Genes make us what we are. They're the basic units of heredity, passed down to us from our parents and our grandparents and all our ancestors. In each cell, the genes are arranged like beads along strands so long that uncoiled they would be more than 3 feet long. These strands are made of DNA, which exists in the nucleus of the cell in the form of a double helix.
All animals rely on cell-to-cell communication. But Diaz and others have been able to show that sponge cells have a unique way of working together. To witness these abilities is to be amazed.
Cell-to-cell communication is very important for all organisms. But in sponges, it's uniquely important because in sponges, cells carry out all the functions that other organisms are taken care of by specific organs, like the heart, or the nervous system, or the skeletal system, or the blood. So sponges have many responsibilities to perform.
Unlike most of our cells, those of sponges retain a special freedom. They can continuously reinvent themselves, performing some truly miraculous feats. If a sponge is passed through a sieve, its cells are separated. But somehow the cells still recognize each other. Over several hours, they begin to come together, building many new sponges. No other plant or animal can resurrect itself this way. What secrets hide within the belly of this beast? The best way to find out is to enter one of the many portals into the sponge's secret inner world. Drifting along with countless single-celled organisms, we feel the tug of a current. In the wonderland within, this sponge's cells all work for the common good, but they do it in wildly different ways. As the current draws us on, we pass sponge cells that are making new spicules. The walls themselves are treacherous. They can simply engulf their unfortunate prey. As we are drawn through ever narrower passages, the current slows until we burst into one of the sponge's millions of tiny beating hearts. These are choanocytes, cells whose whip-like flagellae powers the pump. The flow quickens again as it whisks us away through the labyrinth of canals that lead out into the sponge's central cavity.
Yeast, found in grape juice, for example, has a fundamentally important role in the manufacture of wine. Wine yeast decomposes glucose, produces alcohol, and frees carbon dioxide. Another kind of yeast lives in the dough made from water and flour used to make bread. This yeast also undergoes fermentation that produces carbon dioxide. This gas makes the dough expand, thus giving bread its spongy appearance.